Hello to everybody who's watching this video. Today we have 4 problems. I'm going to do the first problem first, and then we're going to go step by step. We have A, B, C, and D. And we're going to go through all of them, to see what we can have from the question that I get. So the first one we have we have the vector A, vector alley over absolute value of vector alley. And we are trying to get all they ask us for. They want us to find out where there are unit vectors, and there's some stuff that I have to do with you guys to get into this before we begin. So we know we have y hat, x hat, and z hat, and we should know they are in a right hand mode, which we have all of them in perpendicular to each other. So let's say y hat is going up, x hat is going to the right, which is a very normal casual one that we have, and then the z hat going right straight at us, but we can't have a 3D in this, so don't worry about it. We know vector and magnitude is going to be the value that we have for the vector. So this has a very great relationship with that to get us a magnitude. And we know magnitude of the vector has to be 1. I mean, unit vector of the vector is 1, which means we actually get for whatever magnitude the vector has. For example, say vector has a magnitude of 2, then the unit vector is 1. So if the magnitude becomes 4, the unit vector becomes 2, and so on, so on, so on. So that's going to be the relation that how we change the unit vector is vector magnitude. But we have to also know that unit vector is always 1. So whatever vector you're drawing, the unit vector for that is going to be 1. So now we have x hat as 4. Let's say y hat is 3, according to what we have. And it's negative 3 because we're going down. Z hat is 0. Because I'm going to tell you guys how that's going to give an importance for absolute value. So we're going to have 4x hat minus 3y hat. And then we're going to go ahead and find out that, okay, the vector alley absolute value is going to be square root of vector alley minus vector alley. And then we're going to find out, okay, so we have the x hat, y hat, z hat, and then x hat, y, z hat being multiplied together. So that's pretty much all of them being squared in the magnitude. And we're going to get 16 plus 9, because remember, z hat is perpendicular. And one of these hats has to have a 0 for us. So z is 0, because coming right at us, and we don't have it. So 16 plus 9, and the square root of 25 is 5. So we're going to have 5 over 5, 1. This is a unit vector. And the next problem that I'm going to do right in this video, we're going to have see, okay, how can we get the dot product of these vectors to each other? And we're going to do the same thing with the next problems. So I see you guys in the next problem. For the next problem, we're going to have an xn plus y hat. To get a vector, oops, I'm sorry. We're going to have a vector bravo with 3y hat and 3x hat. So let's put up them, and we have an x hat, vector x hat, 3y hat. Sorry, I have to put a hat. And then you find out, okay, we're going to get absolute value over that to get if you can get 1. Now for this problem, we're going to get bravo, and we remember component form. I would love to have it, all the components of a vector is going to be squared anyway. So we're going to 3 squared part 3 squared to get 9. Remember z is 0 again, so we're going to have 0, square root of 18. And then we plug it in, we're not going to get 1, so that's not a unit vector. A is a unit vector, but B is not a unit vector. And then we're going to have z hat, which is coming down on us. Remember, again, the Cartesian rule, which we're going to have perpendicular, so z is 0, x and y are going to have value. And now with this, we're going to go towards c to see if the c is a unit vector. Actually, from what I get from the last problem, the x plus y hat, yeah, we're going to have a unit vector. So x plus y hat is also a unit vector. I forgot the magnitude is going to be square root of 18 instead of being absolute as square root of 18. So we're going to have actually a unit vector on vector on the B problem. But C and D, say we have the square root of 2 and the square root of 2, and then we have the y and z hat. So you know x is a 0, and then you have z and y hat. Or if you have, we even have y hat, it doesn't seem we're going to give like the 1 because you have square root of 2. And we do not know whatever we put on y hat and z hat, or x, y, and z hat, we're not going to get some. We are not sure we're going to get in square root of 2 or square root of 3 over here. That's square root of 3, I'm sorry. So these two are not a unit vector, but B is a unit vector. So we can have 2. A and B are unit vectors. My mistake on last time. And C and D are not unit vectors. So now after this, we're going to get the dot product of all of this. So we're going to go ahead and see if we can get the dot product of the two vectors that we had, A and B. And let's see. So since we find out the vector alpha and vector bravo is going to have a unit vector, we're going to get dot product these two to find out stuff about dot products. So in dot product, we know that it's the two vectors. We're gonna have magnitude of vector alpha, magnitude vector bravo, and cosine of the two angle. So if you know vector b had 3 x hats and 3 y hats, so that's gonna give us a z hat of 0 for both of them. But we know no matter whether magnitude we get a magnitude of square root of 18. We are going to, because it looks like a half of 90, so we're going to have a 45 degrees angle. And vector A has a 4 x hats and 3 y hats, negative 3 y hats. So even though we get a magnitude of 5, it looks like a 30 degrees angle. So we're going to say this is 75 degrees angle. We're going to have 5 times square root of 18, the magnitudes, times the cosine of 75. You're going to get a 5.49, which is pretty much understandable because it's kind of between these two or a little bit higher, which you're supposed to take that as d for dot product. But on the other hand, it's positive, so it's says that this is an acute angle, so it has to have a positive dot product. If it's obtuse, we're gonna get negative, or 90, we're gonna get a 0, which we're not gonna have that anyway. But with this, we have now E dot product. Hopefully you guys enjoyed. This is how we get it. A and B were unit vectors, but C and D were not a unit vector. So that's how we get the unit vectors and a magnitude and dot product and a lot of good stuff. Hopefully